Hi, welcome back to Moose in Chemistry. This is electron configuration of nitrogen lesson. So nitrogen is the 7th element on the periodic table, so we're going to write an atomic number of 7. Its atomic mass or atomic mass unit is 14. Okay, so now since its atomic number is 7, it's going to have 7 protons. And since all atoms are electrically neutral unless otherwise indicated, it's going to have 7 electrons. What about the number of neutrons? Well, to find number of neutrons, you go AMU minus protons equals our neutrons, right? So you go 14 minus 7 equals 7. So we have 7 neutrons. Pretty cool, huh? Now, before we do electron configuration, remember that S can only hold 2 electrons, the P can hold up to 6 electrons, the D can hold up to 10 electrons, and the F can hold up to 14 electrons. Also, when we start going solving electron configurations, it's important to follow the diagonal rule, which we call the off-ball principle. So that's the way we fill our electron shells, and we'll start right here at the top of this slide. All right, so let's go ahead and do the electron configuration. So now when we look at nitrogen, we see that it's 7 electrons. So let's go ahead and start going down the slide here. And as you can see, 1s takes up 2 of those 7 electrons. Pretty cool, huh? So now we come down to the top of the next slide, and we'll work our way down to 2s, and we'll see that it takes up 2 more electrons. So that's 1s2, 2s2. So now we're going to come to the next slide, and we're going to stop at 2p, because 2p can hold up to 6 electrons. But we don't have 6 electrons left, so let's write 2p3. So now let's add this up. 2 and 2 and 3, they make 7. So that electron configuration is absolutely correct. What about orbital notation? Now, orbital notation deals with Hund's rule. So remember that Hund's rule says in every suborbit, you have to put an up arrow first, and all those suborbits, then you can start the down arrows once they're all filled. Well, S only has 1 suborbit, so we go up 1, and then we go down 2s, right? Okay, good. So we go up an arrow, and then down an arrow. Then we go 2px, 2py, and then 2pz, right? So we have, notice that we have 3 electrons here, right? So we're going to go up arrow, up arrow, up arrow, following Hund's rule. And that's it for our orbital notation. What about noble gas notation? Well, noble gas notation is simply this. We look at the nearest noble gas to nitrogen, not the one after nitrogen, but the one before nitrogen, and that would be helium. So we're going to block off helium right here. And then we're going to take our valence shell right here. This is our valence shell. And we're going to add that on to the end of our noble gas notation. So it's going to be 2s2, 2p3. Pretty snarly, huh? Okay, now let's do our quantum notation, our quantum numbers. So we do our quantum notation. We're going to go n, l, m, and s. Now remember, according to the Pauli exclusionary principle, no 2 elements can have the same set of quantum numbers. All right, so what energy level is nitrogen in? It's in the 2nd period, so that makes it number 2. Our N value is 2. Pretty cool, huh? Nitrogen is also found inside the P block. Since it's found in the P block, our L value is going to be 1. Awesome. And now when we count the element nitrogen over from the edge of the P block, we notice it's the 3rd element over, so it's going to have a 1 charge for our M value. Pretty snarly, huh? So look at this last arrow here. It's going up. Since it's going up, it's going to be 1/2 positive for our S value. So that's the set of quantum numbers for nitrogen, which is unique to any other element. Well, that's it. You guys be snarly, and we'll see you back here at Moose in Chemistry.